So in this video, we're going to look at page 35, and hopefully you took some time to try and fill in the answers on your own, and then now are viewing this video to check what's going on. And so in question number 1, part A, it says define the input and output variables. And we're looking at the gas prices in the Phoenix metro area have decreased at a near constant rate during the summer of 2016. And so this table gives us the date, gives us the days since July 23rd, 2016, and the price of gas. So our input is going to be the days since, and then our output is going to be that price. So again, we want to find a letter that makes sense. So D equals the days since July 23rd, 2016. And our output is going to be, how about P equals the price of gas in dollars per gallon. All right, and so find the rate of change for each consecutive set of points in the table. So 0 to 10, 10 to 13, 13 to 18, and show our work and include it. So I'm just going to jump over here to Desmos and have Desmos do our calculations for us. And so an easy way, we can just hit the divide button and start off, and it gives us a fraction automatically. And we're just going to go, again, we need the output, so 2.150 minus 2.080, and on the bottom we have 0 minus 10. And there's our rate of change. For the second set, again, we're going to divide. So we're going to take 2.080 minus 2.059, and this time we're going from day 10 to day 13. And finally, we have 2.059 minus the last price, there's 2.024, and we have 13 minus 18. And so we see that the rate of change is the same for every single one of these. And so we know that our rate of change is equal to negative $0.007 per gallon. So that's how much it's decreasing per gallon per day, and they're all the same answer. So after our calculation. And then so we want to graph this data, and so I'm going to create a table. So I'm going to add a table, and I'm going to type in my inputs and my outputs that are given to me. And the last output, 2.024. And now if I look at my graph, my window for my graph is going from about negative 1 to 19. So I'm going to click on the wrench. I want to go from negative 1 to 19. And then I want to, and I can call this D equals days since 7/23/2016, and then my vertical axis looks to be going from $2 to $2.16. And I'm going to label this as P equals the price of gas dollars per gallon. And then I just click off. And what I'm noticing here is that my points appear to be all now falling in a line. So there's no up and down or jaggedness. So I'm gonna edit this graph, and on my points right here, I want to connect those points, and I can see here that there is no jaggedness or anything. The line in between each one of these points is considered consistent, and so there's no up and down or jaggedness to our line. So when we graph this, we do know that when we connect these points, we are forming a line that is not in any way changing the rate of change, and that's because the rate of change is staying constant now. So if we just look at the definition box on the top of page 35, so a linear relationship is a linear relationship is a linear relationship is when the rate of change between all ordered pairs is the same or constant. So the difference between a slope and a constant rate of change, the slope is the graphical representation of the constant rate of change. So as we can see here, this graph going downward, so we would say the slope is negative because it's going downward, and it is based on what we want to say, the steepness of this is 0.007. The constant rate of change is the constant rate of change is, let's see, let me write it here. The constant rate of change is still the change in output divided by the change in input for all ordered pairs as long as it's the same. The calculation didn't change. We're just now checking to make sure that those rate of changes are all the same.